Hi class, I hope your homework went well last night for 6.1 and that you were able to solve that. Today we're going to look at 6.2. As always with these videos, if at any point you want to practice an example or need more time to write it, please just pause and then continue playing when you are ready. You should have received a blank printout of the notes if that helps you follow along, and then you also will receive copies of the book problems so that you can do your assignment when you are complete with the video. Today in 6.2 we're going to talk about absolute value, square roots, and quadratic equations. The first thing for you to fill in is what the objective is. Yours just says I can, and you want to add solve equations with absolute values and square roots. So that's the key for today. Before we can get into that, we need to remind ourselves of what absolute value means. And you may remember that the basic definition is that it is the distance from zero. Okay. Now one key to think about when thinking about that is remembering that distance must be positive. If I can think about those two things, it should help me understand the idea of absolute value. So if I think about this on a number line, and let's say 0 is right here, positive 32 is over here, negative 32 would be over here. Okay, so positive and negative numbers on a number line, but if I'm strictly talking about the distance from 0, well, the distance from 0 to positive 32 is 32. But again, because distance has to be positive, if I'm simply talking about the distance between 0 and negative 32 or negative 32 and 0, the distance is actually 32. So as you can see by looking at this idea with absolute value, this is where we get to the point that the absolute value of any number, whether it's positive like this 32 or negative like this, we're always going to end up with a positive answer. Having said that, the formal way of looking at that is that the absolute value of x equals positive x for x greater than or equal to 0, and it's negative x for x less than 0. Now I will say for me this definition always gets confusing, so I really just like to think about it this way. The formal definition throws me off sometimes. Okay, but I do think about that idea because if I want to solve something with absolute values like this particular example, absolute value of x minus 4 equals 8.1, I think about the fact that if I get rid of the absolute values, the absolute value of x minus 4 can actually equal 8.1 for x greater than or equal to 0 and negative 8.1 for x less than 0. If I follow that definition I just wrote down. What that means is I need to take this, and to get rid of the absolute value, I need to take into account that the x minus 4 without absolute value could be positive 8.1, or x minus 4 could be negative 8.1. And then I can just solve both of these individually. I get x equals 12.1 and x equals negative 4.1. So as you can see, when you solve absolute value equations, you set it equal to the positive and negative once the absolute value is all by itself, and then you just solve algebraically. Take a minute and try this one on your own. When you've completed it, you come back to the video and see the solution, so pause at this time. What you should have done is done x plus 6 equals positive 7.2 and x plus 6 equals negative 7.2. Subtract 6 here, you should get x equals 1.2. Subtract 6 here, and you get x equals negative 13.2. Those should have been your two answers. Now that we've reviewed the ideas of absolute value, now we're going to combine it and look at square roots as well. For this activity, we're going to look at f of x being the square root of x squared, and g of x being the absolute value of x. Over here on the right, we have a table where it gives us different constraints. We're going to pick an x value, and then figure out what the f of x would be given that x, and what g of x would be given that x. So for example, if I want to pick a value when x is less than negative 10, I could pick negative 12, for example. Anything less than negative 10. Well, if x is negative 12, and f of x is the square root of x squared, then I would do f of negative 12, which means I do the square root of negative 12 squared. Well, negative 12 times negative 12 is positive 144, and the square root of 144 is 12. So when I plug in negative 12 for f of x, I get positive 12. We said the g of x function is the absolute value of x, and so if I do g of negative 12, we just reviewed that the absolute value of any number is going to be positive because it's the distance from 0. So g of x is also positive 12. Take a minute and go through and fill in the table. When I did between negative 1 and negative 10, I used the number negative 5. You can use whatever you want. For 0 to negative 1 to 0, I did negative 1/2. You can see zeros are already done for you. Then I picked positive 1/2, positive 5, and positive 12. So pause it again, go through and fill out f of x and g of x, and then I want you to make a conjecture about the relationship between f and g. So what you should have gotten when you went through and did this is for negative 5, you should have gotten 5 for both f and g. For negative 1/2, you should have gotten positive 1/2 for both f and g. Positive 1/2, you get positive 1/2 for both. Positive 5, you get positive 5 for both. And positive 12, you get positive 12 for both. So hopefully what you're recognizing when you're talking about conjecture between f and g is that all the values of f of x are the same as the values of g of x. So my conjecture from step 2 would be that I think f of x equals g of x. If in fact that's true, I would be able to conclude by substitution that the square root of x squared equals the absolute value of x. And that is in fact true. They ask us to graph it just to verify that that's the idea. If I go negative 12 up to 12, then I'd go positive 12 up to 12. That was a point on both. I had a point at negative 5 and positive 5, 5. So if you went through and graphed it, these should have been the points you got. We had 1/2, 1/2, negative 1/2, 1/2. Now hopefully we know if we were to actually graph them, the absolute value should be in the G shape, or V shape, sorry, V, whereas the x squared of x squared, actually the square root of x squared would be the same, but those points all match up, so square root of x squared is actually equal to the absolute value of x. This is known as the absolute value square root theorem. I won't test you on that, but it's good for you to have heard it. Absolute value square root theorem. The reason we bring this up now is because next we are going to start looking at examples of solving when we have x squareds, and it's going to follow the same idea that if I have the square root, if I take the square roots of both sides, I'm going to need to have the positive and negative answer, just like if I get rid of the absolute value signs, I have a positive and a negative. So in this case, if I'm going to solve for x, hopefully you remember, to get rid of a square, I can square root it. As a reminder, as long as this power matches the index right here, which if there isn't an index, it's the same as having a 2, it cancels them out. And then if I follow my rules of algebra, I know the rule that I can do anything I want as long as I do it to both sides. So if I square root this side to get rid of the x squared, it just means I square root the other side. That theorem that we just learned tells me, though, that if I take the square root of an x squared, which we just did, it's going to equal the positive and negative of square root of 12. Now eventually we're going to learn how to simplify the square root of 12 by hand. Some of you have the Inspire calculators. If you type that into your calculator, it'll probably give you a simplified answer. It technically is equal to positive or negative 3 root 2. Again, don't worry right now about how I figured that out by hand, but you could also give me the decimal, which would be positive and negative 3.46. Again, the key is, if you square root an x squared, you always want two answers. It's going to be the plus and minus of what you get. Take a minute, try this example on your own, pause it, and when you've completed it, check your work. Again, because I have x squared equals 40, to get rid of the x squared, I square root of both sides. I get x equals, because I took the square root of square root of x squared, I get plus or minus square root of 40, which would be technically plus or minus 2 root 10. But again, this would be the answer you wouldn't know how to get yet. The decimal version would be 6.32. So x is plus or minus 6.32. Again, some of you guys will be typing it in your calculator and you'll get the 2 root 10. Next, we're going to look at a real-world example. This one says a square and a circle have the same area. The square has side length 15 units. Which is longer, a side of the square or the diameter of the circle? First of all, because it's a square, that means if this side is 15, this side is also 15. We're saying they have the same area, which makes me know I need the area formula for both. Area of a square rectangle is base times height. We reviewed that yesterday. Area of a circle we didn't quite get to yesterday. That's pi r squared. So quickly and easily I can find the area of the square, which I think I might need to do. So I do 15 times 15. The area of that square is going to be 225 units squared. The reason that helps me is because I know they have the same area. So if I have area equals pi r squared, which is a circle, I know the area must be 225. And now, because I only have the r left, I'm able to solve for r. I would divide by pi. And when I did this on my calculator, I did 225 divided by 3.14 because I only had a baby calculator. If you do 225 divided by pi on your graphing calculator, you may get something just slightly different because it obviously went round that much. I got 71.656, and that is equal to r squared. And now we're back to what we just learned. To get rid of an r squared, I would square root both sides. Here's the key though. The reason we do this example is because now we're in the real world. I'm finding the radius of something. So we said when we're just solving equations, if we take the square root of an x squared or square root of an r squared, we always get two answers, a positive and a negative. In this case, however, because I'm finding the radius, just like distance, I know the radius has to be positive. So for the real world application, I'm going to just take the positive. And when I took the square root of that, I got about 8.5. Now the question itself, we need to make sure we answer. It says, which is longer, the side of the square or the diameter of the circle? So my whole goal has been to find those two things. Well, they tell me that the side of the square is 15. I've been working to find the diameter. Well, I found radius. Now it's important to know that diameter is 2 times r. So since I know my r is 8.5, my diameter of the circle would be 17, or about 17 since I rounded. So if my diameter is 17 units squared, the answer to the question is the diameter of the circle is longer. Because we're getting into these types of things where we're taking square roots of not very nice, neat numbers, one thing I wanted to review was rational and irrational numbers. So very quickly, a rational number can be written as a simple fraction, such as a over b. If it's as a decimal, it's a non-repeating decimal. Okay. Irrational answers would be similar to the last few that we've seen. Irrational numbers have infinite sorry, this one was supposed to say repeating decimal. Ignore this. It's a finite decimal, is what I meant to say. So an example, back to this, an example of this would be like 3 over 2. An example of a finite decimal then would be 1.5. It just stops, it doesn't keep going. This is an infinite non-repeating decimal.